Okay, so today we will start dynamic with pulleys. Let's initially see what is a pulley. So if we have an object, or pulley is a like two masses that are tied together, mass 1 and mass 2, and are going through a pulley. And the assumption that we are doing here is that there is no friction when the rope is going around the pulley, and for the string, there is no elasticity. So the string is not going to be compressed or expanded as a result of the masses that we are tying up to the end of the string. Now, the pulleys usually are with two different masses because there is no sense to have the same mass in both sides of the rope. So the way that we will approach a pulley is in the same way as we have done in the other examples in dynamics. So let's give some numbers here, and let's say that the mass 1 is 3.0 kilograms and mass 2 is 5.0 kilograms. Based on this situation, we have an assumption that the pulley will move in one direction, either clockwise or counterclockwise. And since mass 2, that is on the right, is greater than mass 1, then the assumption is that the pulley will move clockwise. So then what do we do? This is the situational diagram. What do we do is we start building the free body diagram. And we start building the free body diagram for each of the object 1 and object 2, because we have two, object 1 and object 2, mass 1 and mass 2. So the object of our interest, in the case object 1, is represented by a dot, which the whole mass of object 1 is concentrated to. And we start with the universal force, that is universal force of gravity. And just to make sure that we are talking about object 1, I write the index 1 here. And then since we have a string, because we kind of cup this, since we have the string, then the string will be replaced by force of tension. Now, you notice here that I do not have index 1 for tension, because we are dealing with one rope here. So the rope goes from object 1 around the pulley and then is tied with object 2. So therefore, when the two objects are, it doesn't matter that they are going around the pulley. They may be in a straight line, or maybe in a pulley, or in different pulleys. So when we the two masses that are tied with a string are tied with one string. Therefore, the tension on every section of this string will be the same. So what we are doing here, the magnitude of the tension of a single string that is tying two objects is the same. The direction may change depending on how the string goes. And we will see examples like this. So therefore, the tension on every section of the string will be the same. And this is why I do not put an index 1 for tension on free body diagram of object 1. Okay, And then we move to the free body diagram of object 2, where the object of our interest is represented by a dot, and then we have the universal force that is force of gravity 2, and then we have a tension T. Again, here I do not state that this is a tension for the second string, because it is one string. As long as you see that the string is connecting one object with the other, the tension on each section of that string is the same. Okay? Now, object 1 is moving up based on the assumption that we did that the object or the pulley is moving counterclockwise. So object 1 is moving up and object 2 is going down. Okay, so now if we draw the X and Y axis, normal X and Y axis, or normal horizontal and vertical axis, as we have seen in math, then what do we do is we complete or construct the table of components. So for object 1, what we will have is horizontal and vertical, and forces that we are dealing with are force of gravity 1, tension, and since there is no other forces that the object is experiencing, is force net. One more thing that I want to emphasize here is that we are building the table of components for both objects. So object 1 and object 2, horizontal and vertical. And then we have force of gravity 2, tension, force net. Okay, in the horizontal, the magnitude or the magnitude of the horizontal component of force of gravity is equal to 0, since we have a force that is perpendicular to the axis, and the vertical component is negative because it is in the opposite of the positive vertical axis, 3.0 times 9.81. And for the tension, since it is perpendicular to the horizontal, is equal to 0, and the vertical component of the tension is positive because it is on the same direction as the positive direction of vertical axis, and it is positive T. So we don't know what T is. Now, in the horizontal direction, the object is not moving. It's the same idea as we said at the incline, that in the vertical direction, the object is not moving, because another assumption that we are doing here is that no wind is affecting the motion of the pulley. So there is no wind to push the pulley or the object in the horizontal direction. So therefore, since the acceleration on this direction is equal to 0, then force net on that direction is equal to 0. And since the object is moving in the vertical direction, because we see that it's going up, then will be mass 1 times acceleration. Now, for the first object. Now, is it positive or is it negative? Since the object is object 1 is moving up, is moving on the same direction as the positive vertical. So this will be a positive value. Let's move now to object 2, where we have to find the horizontal component and the vertical component of object 2. And now we know that everything in the horizontal is equal to 0. And on the vertical, what do we have? Force of gravity is negative because it is in the opposite direction of the positive y-axis or vertical axis, and will be 5.0 times 9.81. And tension is as well positive, the same way and the same logic as we said for object 1 is on the positive direction of the vertical axis. And object 2 now, this object here, we are saying that is going down. So here we are stating it even here, that is going down. Therefore, going down means that is the opposite of the positive vertical axis. And it is mass 2 times acceleration. Is this clear? So now, when you see this table, you see that the horizontal components are pointless. And then what we can figure out from the vertical component of object 1, 3 times 9.81, is negative 29.43 plus t is equal to mass 1, that is 3 times acceleration. And this is as a result of the vertical component of object 1. And then for the object 2, what do we have is 5 times 9.81 is negative 49.05 plus t is equal to negative 5 times acceleration. And this is from the second object, or the vertical component of the second object. Now, what do we see here from the mathematical perspective is that we have two equations, equation 1 and equation 2, with two variables, the tension and the acceleration. Now we are solving it. We can solve it any way we want. However, the easiest way, since the coefficients are close to t, or the coefficients of t are 1 or equal to each other, and the sign is positive, we can subtract the two. And when we are subtracting the two equations, what we will have is negative 29.43 plus t minus negative 49.05 plus t equals to 3 times a minus negative 5 times a. Okay, so this negative sign here is affecting both terms, the negative 49.05 and positive t. So then what we are having here is negative 29.43 plus t. Negative and negative will give us positive 49.05 minus, because negative and positive will give you negative, and this will be 3.0 times a. Negative and negative will be positive 8.0, sorry, 5.0. I was going 5.0 a. So now the positive and the negative t are canceled out, and then what we have is negative 29.43 plus 49.05 until 43 will be positive 19.62 equals to 8a. And then when you divide both sides by 8, you will find that the acceleration is equal to 2.45 meters per second squared. Is it clear? Okay, so now after we find what the acceleration is, then we can go to any of the equation 1 or equation 2 to figure out what is the tension on the string. So I will pick equation 1 just for simplicity, but you should have the same result picking equation 1 or equation 2. And this may be an opportunity for you to test if the question is right or not. So you take this value and then you substitute it once to equation 1, you will have a value for t, and then see if is the same value for when you substitute the value of 2.45 in this case to equation 2. So negative 29.43 plus t is equal to 3 times acceleration, which in our case is, we just found it, 2.45. So from here, t will be 3.0 times 2.45 plus 29.43. And it is 36 point, you can say 8, it's fine, or 36.78. And on this case, again, the same logic as we did in the previous lesson, we are not defining what is the direction of the tension, because we have done all of the work prior to this. So what we are finding the magnitude of the acceleration, the magnitude of the tension, because in order to come to this point, we have dealt with situational diagram, we have dealt with free body diagram, and then we have built all of the equations for coming from the free body diagram and reaching the conclusion that the acceleration of the object is 2.45 and the tension of the string is 36.8. At every section may be a different direction depending on how the string is configured, I should say, but the magnitude at every section of the string is 36.8 newtons. Now, another thing that we have to keep in mind here is that even the acceleration is the same in magnitude. May be different in direction. So let's say for object 1 is going up, for object 2 is going down, but in terms of the magnitude, it is the same magnitude. Question? Okay, so let's suppose that we have a pulley now, and the masses of the object are, for object 1 is, mass 1 is 15 kilograms, and for object 2, mass 2 is 7 kilograms. However, as the very first step, we said that is to define the direction of the motion. However, even though that your natural way will be that it is counterclockwise because mass 1 is greater than mass 2, I will say that no, I will pick clockwise just for fun. And then based on this, I will draw the free body diagram for both object 1 and object 2. And now the same way as we have done at every free body diagram, we will have for the first object will be the universal force of gravity, which is 15 times 9.81 equals to 147.5 newtons. And tension, that is the same logic. It is starting from the object, going along the string. There is no other forces here. Again, force normal is the main confusion for the students. The force normal doesn't exist here because the object is not on the surface, is not on the top of the surface. The free body diagram for object 2 will be dealing with the same logic. The object of our interest is represented by a dot. starting with the universal force of gravity. 7 times 9.81 is 68.67, and tension, that is starting from the object going along the string. Based on our direction, object 1 is going up and object 2 is going down. Are we clear up to this point? So let's start building the table of components for object 1, horizontal and vertical. We will have force of gravity 1, tension, and force net. On the horizontal, all of the forces are equal to 0. And on the vertical, what we have is the force of gravity is negative 147.5. Tension is positive T, and acceleration will be positive because we are saying that the object is moving up, okay? Positive 15 times acceleration. Using the same logic, we will construct the table of components for object 1, horizontal, vertical, force of gravity 2, tension, and force net. Horizontals are all zeros because the object is not moving in reference to the horizontal axis. And the vertical will be negative 68.67. Tension will be positive T. And since we are saying that object 2 is going down, it's opposite of the positive vertical axis. So will be negative 7 times A. So as you see from this relationship, the horizontal components are pointless. So from the first vertical component of the first object, what do we have is negative 147.5 plus T is equal to positive 15 times A. And from the vertical component of object 2, what do we have is a negative 68.67 plus T equals to negative 7 times A. If you subtract the two together, what you will have is a negative 147 this is 0.15, not 0.5. 0.15. So 0.2, you can say 0.2, but 0.15 plus, because negative and negative will give you positive, plus 68.67. It is negative 78.48. And positive T minus positive T will be canceling out, equals to 15 plus or minus and minus will give you positive. So 15 plus 7 will be equals to positive 22 times A. You divide both sides by positive 22. Then acceleration will be 78.48 divided by 22 will be 3.57. 3.57 with negative meters per second squared. This negative, when we do not have the negative sign of the acceleration when we do not have a friction, and in pulleys we don't have friction, means that the direction that we have chosen is the opposite, is not right. So what do you have to state in the cases of the pulley when you are dealing with coming out as an acceleration and negative is you have to check your direction and say that acceleration is 3.57 meters per second squared, but now is counterclockwise, not clockwise. And then you take this value and you substitute it in any of the equations, either equation 1 or equation 2, and figure out what is the tension. Now there are